And we're beginning. Good morning, this is Mr. Barre. This is Math 1. It is the 11th of March, 2020, and we're going to talk about some proofs using and midpoint and what's the other word up there? Bisectors. Bisectors. All right, so we got a couple things we're going to put into our notes. Here is the first one, a midpoint. A midpoint is in the middle. So if I have a segment, there's a segment, and I put a point in the midpoint, I put that in the midpoint. When I put something in the midpoint, I get two equal segments. Those two guys are equal. Does that seem reasonable?
Yep.
Yeah. Right in the middle means there's half on that side and half on that side. So if this is 7 inches, what's this?
7 inches.
If this is a foot, what's this?
Foot.
If this is a mile, what's that?
Mile.
There you go. That's the midpoint. Questions on midpoint? Questions on moving this over here so people can see what I'm talking about? There's midpoint. Next one is a bisector, I think. Bisector? Bisector. It's a bisector. Next box. Bisector. What does a bisector do?
Cut segment.
Cuts it in half.
Is this under in the same box?
Second box. So if I have this segment right here, it was this class, right? I talked about how I was in Mulan.
Oh yeah.
Oh yeah. The golf.
And the golf. Oh yeah. And the cricket and the lacrosse. Lacrosse. Lacrosse.
And bowling.
And bowling. How about curling? You know curling?
Yeah.
So if I take my bisector, I can bisect boom, 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 boom. Yeah? And I'm cutting it directly in half. Remember?
Like how you tried to cut that paper in half?
Yes, like that. Now notice I'm intentionally making it at some strange angle. Boom, boom. I know that doesn't look like a good bisector there on mine, but make yours look better. It creates two equal segments. Cool? So if this is a foot, what's this?
A foot.
If this is a mile, what's this?
Mile.
If this is 3 centimeters, what's this?
3 centimeters.
But now, notice when I bisected, I was like, boom, boom, or boom, or boom, or boom, or boom. Yeah?
You're gonna hit yourself in the face with something.
You could be a lightsaber.
Right? I'm in Mulan. I'm in Mulan. You look for me.
You.
Yep, in the background of the big battle scene.
All right.
Mr. Barre.
Mr. Barre's like going
Now, so that's a bisector, but our next one is a perpendicular bisector. So I start with my little segment. My segment. Bisector. Perpendicular bisector. Bisector. Perpendicular bisector.
I like that.
Yeah?
Ooh.
You got it?
That's nice.
So when I do my perpendicular bisector, here it is. It bisects it, but it's perpendicular. I put those little 90-degree guys in there, show you it's perpendicular.
Mine is not straight.
Perpendicular bisector. Oh, I didn't even go to that slide yet here. There it is, perpendicular bisector. Cuts it in half and is perpendicular.
Does it keep going?
This,
Yeah.
it can because it's got arrows on it. We have space, we have another box, don't we?
Yeah.
You don't have to write this down. A geometric proof is a step-by-step explanation that uses definitions, axioms, postulates, and previously proved theorems to draw a conclusion about a geometric statement. You guys did a mock trial in Bess's class?
And
Yeah.
Did you have a whole bunch of evidence?
Yeah.
And you had to kind of put it together
Yeah.
in the right order
Yeah.
and make an argument?
Yeah.
That's what proofs are, just mathematically.
So
We're going to have evidence and we're going to put it together to prove something. We're going to prove that Andrew Jackson is guilty of being a jerk. Was he guilty of what? High,
Abuse of power and.
high crimes and misdemeanors? Misdemeanors? Yes?
Sure.
It's okay. It's not really a knife, it's a
Yeah. Thought you were gonna
Next one. We can do this one in one box. It's going to be two things, but we'll put them in the next box. CPTC. CPTTC. CPTCP. Corresponding.
Wait, is CPT?
Corresponding parts of. I've messed it up. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent.
Who came up with this theory?
Bob.
Bob the Builder?
Yes, he did. Bob the Builder. Yes, he did. And what this means is, if the two things are congruent, all their parts are congruent. So, let's say that Gordon and I are congruent people. We are the exact same person, both in thought and in physicality. We are the same person. We're congruent. So, are our left hands the same?
Yes.
Yes, even though I'm holding up my right hand. Do we have the same eye color?
Yeah.
Yes. Are we the same height? Yes. Do we wear the same size shoe? Yes. But if we are congruent. So this is saying if two triangles are congruent, then all their parts are congruent. Are their angles congruent?
Yes.
Yes. Are their sides congruent?
Yes.
Yes. That's what that says. So if the two triangles are congruent, then you know all the parts are congruent. And now, our final one is the reflexive property.
Do you want us to make your vote?
Yes. This is can be in the same box. Reflexive property. This one says, I am congruent to myself. Right here, segment AB, is this segment congruent to this segment?
Yeah.
It is. That's the reflexive property. Oh, how about this? Is this segment congruent to this segment?
Yeah.
Yes, that's the reflexive property. Oh, how about this one? Is this angle right here congruent to this angle right here?
Yeah.
It is. That's the reflexive property.
So it's just like looking at this.
Oh, look at this. Hey, is this segment congruent to this segment?
Yeah.
That's the reflexive property. Am I the same height as Mr. Barr?
Yeah.
Yes, that's the reflexive property. Hey, does Nico weigh the same as Nico?
Yeah.
That's the reflexive property. Beg your pardon?
Why is that one? Why is that?
Why is that a property?
Yeah.
Because there are going to be times that we're going to have to say, hey, this guy right here, we're actually using it in two different triangles, but it is the same piece. So this guy right here, is he a part of this triangle?
No. Oh, yes.
Yes. Is he a part of this triangle?
Yes.
So, okay, ready? Are these two guys congruent? I'm
Yes.
telling you they are. Ready? Are those two guys congruent?
Yeah.
Yes. Ready? is this guy, if I split it up, is he congruent to the part on this triangle and this triangle? You see how it's two? That's when I'm going to be using it. When it's like an overlapping side. I'm going to say, hey, this is congruent to itself. How do you know that? Reflexive property. That's my argument for it. Like in a mock trial, you've got to have the reason why you can say something. Okay. It's going to be a good day. It's fine. You go, okay. Get out a whiteboard and a marker.
I don't really like whiteboard markers. They make a mess.
New one. I got a brand new one. There's our new whiteboard?
There's one new whiteboard out there. One. Who's getting you a whiteboard?
Look at the clean edges too.
Let me see.
Greenlee, you're an enabler.
Look at that.
Trent needs to work for himself.
Are both sides minutes, Aiden?
All right, Bradley, here we go. Here we go.
Where did that even come from? I did not see that.
What, Mr. Barre?
Here we go. Go to slide number, whatever that is, 1. Go there. You're going to see a geometric proof. Here's how it works. It's like a lawyer with evidence. You've got all the known stuff, all the evidence that you have, and slowly you build up the case. And you use rules of law and arguments, things about hearsay and eyewitnesses and objections, and you're building up the case to prove it. So right here, W is the midpoint of VX. Complete the proof and prove that this triangle is identical to that triangle, congruent. What's that?
Because they have the same amount of lines.
Well, let's walk through this. I'll tell you when to write. W is the midpoint of VX. How do I know that? How do I know that? No. How do I know that?
Because it says.
Because it says it. Because I gave that to you. That's called a given. I gave that to you. Vy is congruent to xz. Vy is congruent to xz. How do we know that's true? Because I gave that to you. I told that to you when I gave you the image. That was given to you. This is your evidence. Wy is congruent to wz. These guys are congruent. How do I know that? Because I gave it to you. I showed that on the diagram, right? It was already there when we started the problem. I didn't make it up. It was there. VW, this guy right here, is congruent, let me put 3 on that one, to this one.
Yes.
How do I know that?
It is given.
That wasn't given.
Oh.
It's a condition.
Oh. Definition of a midpoint.
It's the definition of the midpoint. Did I tell you it was the midpoint?
No.
I didn't?
Oh, yeah.
You told us
Yeah,
that
you
was
said
definitely-
W is the midpoint.
No. Did I tell you that this is the midpoint? Did I tell you that? I didn't tell you that?
No, W is the
W is the midpoint. Did I tell you that?
Yeah.
Oh, I gave you that. If W is the midpoint, are these guys the same distance?
Yes.
Yes, if this is 7, what's this?
Seven.
If this is a foot, this is...
Foot.
Okay. How do you know that? No, I didn't tell you that. Definition of midpoint. I told you it was the midpoint, and you said, oh, that makes 2 equal segments.
No, it's not.
Definition of midpoint. Okay. Are these 2 triangles congruent?
Yeah.
On your whiteboard, tell me why. It's going back to what you did yesterday for homework. And tell me why those 2 are congruent. Okay. Do I have a marker? See if Fisher has a marker for you. You don't have to write me a whole sentence. You're writing me 3 letters.
Oh.
Yes, yes. No. Are they congruent? I'm asking you why they're congruent. Yes, yes, yes.
Why'd you do this backwards?
Good. They are congruent because of side, side, side. You're going to end almost every proof with side, 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 angle, side, angle, side, angle. That's the final kind of step. We're going to do another one. You erase your board. I've given you this picture.
It's a beautiful picture.
Beautiful picture. Let's start with the proof. VW equals UW. VW is congruent to UW.
Given.
Given. That was on the picture. SW equals TW.
Yes, given.
Given. That was on the picture. Ooh. SWV. SWV. This angle is congruent to that angle. Those are brand new. I just drew that on, right? So that wasn't a given. How do you know that's true?
Vertical angle.
He's right. Vertical angles.
I know, I understand, like, that wasn't like what you were asking.
No, how do I know those are congruent? Because they're vertical angles. And it also says it right here, vertical angles. Yes? Okay. Now, how do you know that the 2 triangles are congruent? Write that on your whiteboard. Good. Oh! That was pretty close, man.
No one to say anything. Yeah, it is. Yeah,
Ow. That hurts. Okay. Good, good, good. How about you? Good, 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 good. It is by side, angle, side that they're congruent. They're congruent by side, angle, side. Next one. Ooh.
Were we trying to figure out, like, all 3 of them are congruent?
Well, we'll figure it out. We're actually trying to prove that FGH, this one, and this one are congruent. Triangle EFH, that one right there is equilateral. How do we know that's true?
It's given.
It's given. Angle HEI, this angle and that angle are congruent. How do you know they're congruent?
Because it's given to us.
It was given to us where? Up at the very top. Equilateral was given. That's given. Okay. EI is congruent to FG. EI is congruent to FG.
It says it at the top.
Oh, that's given. It says it at the top. Right. Ooh, how about this one? EH is congruent to FH. EH. Those guys are congruent. Why? No. Yes. Don't tell anybody. Yes. No. Reflexive is that I am the same as myself. Those are 2 distinct sides. Good job, JJ. No. I would use that only after I proved congruency. That would come after a SAS. Nope, that wasn't a given. Nowhere in the given does it say that EH and FH. It's based off of a given somewhere else. Yes, that's exactly right. What you did. It's not in your notes. It's based off of a knowledge that I expect you to have.
Pretty sure I spoke the thing now.
That's right, though. Go back to the givens. Read the givens to yourself. One of those, yes. One of those givens supports what I just said. Yes.
I don't know if that's spelled right, but.
Yes. What's an equilateral triangle? Equilateral triangle. Everything, every part of this triangle is the same. It's an equilateral triangle, which means those two sides are the same. Why? Because it's an equilateral triangle.
So
I'd write it's an equilateral triangle, or definition of an equilateral triangle. Cool. And then how do I know that these two triangles are the same? Write it on your whiteboard. How do I know that this is equal to that? Good, good. Good, good. I know it by? How do I know they're congruent? That's what I'm asking to write. SAS. Good. K is the midpoint. How do I know that, Maddie? How do I know that K is the midpoint?
Because HI and HJ
I'm going to come back to you. JJ, how do I know that it's the midpoint? It's given. I told you it was the midpoint. Right there, it's the midpoint. Yeah, given. HI is congruent to HJ. HI. Oh, so I'm going to put that midpoint up here, though. Ready? I'm going to make a dot right there. Midpoint. Yay. Midpoint. How do I know that this is congruent to that? How do I know that, Lizette? How do I know this is the same as that? It's given. Ooh. IK equals JK. IK equals JK. How do I know that? Perfect. Not reflexive. Reflexive is saying that I am the same as myself. Yes. Yes, yes. Write that down. Good, 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 good. Not a median. Nowhere in this was median ever brought up. What was brought up? Midpoint. I just used my midpoint. Definition of midpoint. KH is the same as KH. What is that? Write it on your whiteboard. KH is the same as KH. I'm the same as myself. KH is the same as KH. Or HK. Good. 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 Good.
Ignore that.
It reflexive?
Reflective.
Reflective.
I spelled it really wrong.
Reflective property. Good. So now I've got, how can I prove that the triangles are congruent? Side, side, side. Brings it all together. W is the midpoint of UV. How do I know that, Maddie?
It's given.
Good, I'm going to put it right there. Put it as the midpoint. TW is perpendicular to UV. How do I know that? Taryn, how do I know TW is perpendicular to UV? It's given. Look, and I put it right there. angle TWU, this guy is congruent to that guy. How do I know that one? Start looking at your paper.
I probably spelled that wrong.
You're really close to it, but it's not that. Here, look through it, because there's something that just says perpendicular. These are your options right here. You're going down this one right here. This is not a perpendicular bisector. Nowhere does it say it's a perpendicular bisector, so you can't use that. Angle bisector cuts an angle in half. This isn't necessary. Doesn't say anything about angle bisector. Do you see anywhere up there something that says bisector? You can't use bisecting. Nico, you got it.
Oh, God.
You have it. You find it. Really find it on this thing. That comes at the very end of a proof. No.
Oh, I see.
Definition of midpoint says it makes two equal segments. Doesn't say anything about angles. It's not reflexive because this angle is not the same exact angle. It's the same measurement, but it's. Read down all the reasons on that paper.
Ellie.
On this paper, like.
On the paper that I gave you. It's one of those reasons.
Wait, from today?
On the paper that I gave you today, it's all the reasons you're ever going to need. Nope.
I don't think that
Nope.
makes sense for us. Yeah.
They are congruent, but why are they congruent? Those aren't vertical angles. They're not vertical angles. Midpoint doesn't tell me anything about angles. Midpoint tells me that the middle. Yes.
What?
Property of congruence, is that even on the paper?
Yeah.
As a standalone property of congruence?
It reflects it. Properly.
Yes. I don't know this is equilateral, it doesn't mention that. I have doesn't tell me it's perpendicular bisector at all. It tells me it's perpendicular. Yes. Alternate interiors, so we're going to have parallel lines cut by a transversal. We're going to have parallel lines cut by a transversal.
Wait, I think I know what it is.
Yes. Alternate exteriors are when I have two parallel lines cut by a transversal. That's not parallel lines cut by a transversal.
Dang it.
Corresponding angle theorem is when I have parallel lines cut by a transversal. This is not parallel lines cut by a transversal.
Tomorrow,
Beg your pardon?
or the concludes tomorrow.
What concludes tomorrow?
The concludes.
No, we're not taking a test till next week.
Oh,
Barre?
Yes. Read it to me. Alternate interiors are when I have two parallel lines cut by a transversal. That's not this. Yes.
Wait,
Yes.
is it?
No.
No.
you just have to.
All right.
See, I kept on thinking.
I'm going to read things to you.
Oh, wait. Oh, I know what it is.
Is it a given?
No.
Is it just congruent?
No.
Reflexive?
No.
SAS, ASA, SSS, SSA, la 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 la.
No, no,
Okay.
No.
Definition of midpoint.
No.
Definition of a segment bisector.
No.
Definition of a perpendicular bisector.
No.
No. Definition of an angle bisector. No.
No.
All right angles are congruent.
Yes.
Not so nice.
All right angles are congruent. If this is a right angle, which I know it is, and that's a right angle, which I know it is, then they're congruent to each other.
So
That makes
All
me
right
so
angles are
mad.
congruent.
I'm getting so frustrated.
It's right there on your paper.
I didn't even.
Did you read that?
I did.
You did?
Not. Okay,
Good.
can we start up?
How do I know that this is congruent to that? On your whiteboard.
What do you think?
Reflexive is something is identical to itself. Good, good. There it is. Good. Not it is.
Wait, are we allowed to use this on the test?
I do not know.
Please, 'cause I can't remember all of this.
Good.
Oh, wait, I'm ahead.
Good. This is midpoint.
You're not wrong. It's all over me.
We're on 4 right now.
Oh. How about this one? TW is congruent to TW. TW is congruent to TW. There we go. Now you're catching that. TW is congruent to TW. Good. Good.
No, this is the one thing I can do.
Good. You can do reflexive property.
Yes.
Reflexive property.
It's easy because you remember reflexive because it's like reflecting.
Okay.
Huh?
Yes.
That's how I remember it. Makes sense.
So here are my triangles. How do I know that these two triangles are congruent?
You know.
Yes. Yes. Is that the last one?
Yes.
Yes.
I know this one.
How do I know those two triangles are congruent? Good. Yes.
Sounded like a barber.
Perpendicular bisector doesn't prove triangles are congruent.
Oh, wait, yeah.
Good. 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 Good.
I already did.
Okay. SAS. Side, angle, side. Before you begin the IXL, if you are getting things wrong, I highly recommend, actually, if you're getting them wrong and you want help, before you get help, you need to start drawing the triangles down in your notebook.
On the whiteboard?
No, in your notebook. And marking them up on the paper. And then you can come and get help from me. But if you're not going to draw anything down, I'm not going to help you write anything down. I'm going to give you one hint. You're going to see some problems that look like this, where it's overlapping triangles. Break it up. Like that, and it'll make it easier to work with. When it's talking about overlapping triangles, break it up, and then label it, and then mark it all up. Write down the triangles, mark it up, and then finish off the proofs. We're done. Stop streaming.